Hello friends, myself Professor Joshi VM from Arsus Technical Campus CHAS, Ahmednagar. Last lecture we have discussed about numericals of transformer. In this lecture we also discuss and solve some important numericals of transformer subject. So let's start our session. The numerical is a load of 15 kVA at 1400 volt and zero point 0.8 power factor to be supplied from a 2500 volt using auto transformer. Determine secondary power input and output current uh, and comment on a saving of copper in an auto transformer with two winding transformer of same rating. So this numerical is given. First of all we have to write here a given data. So the given data is kVA rating equals to kVA rating equals to 15 kVA and power factor is also given. Power factor is cos phi equals to 1. Okay, after that V1 is also given. V1 equals to 2500 volt. V2 is given 1400 volt. So primary current, first step we calculate here primary current equals to I1 equals to kVA into 10 raised to 3 upon V1. We know the formula. Primary current I1 equals to kVA into 10 raised to 3 into V1. So by putting the all values, kVA is given 15 into 10 raised to 3 upon V1 is given here 2500. We calculate here primary current by using the formula I1 equals to kVA into 10 raised to 3 upon V1. So by putting all the values, kVA value is 15 into 10 raised to 3 upon 2500. By solving this we can get 6 ampere current. Okay, 6 ampere current. After that in second step we calculate here a load current I2. Use the same formula, only replace here V1 V2 instead of the V1. Then the formula is kVA into 10 raised to 3 upon V2. By putting all the values we will get 15 into 10 raised to 3 upon the given V2 is 1400, and by solving this equation we will get the load current I2 equals to 10.7474 ampere. Okay, 10.74 ampere. So let's calculate I2 minus. Here the examiner asked for the comment on saving of copper. So now we concentrate on saving of copper. The saving of copper I2 minus I1 equals to 10.74 minus 6 equals to 4.74 ampere. I2 minus I1 equals to 10.74 minus 6 equals to 4.74 ampere. After that, the secondary power equals to P equals to V2 I2 cos of phi. Okay, we know the value of V2. The value of V2 is 1400 into I2 we calculate already 4.74 into 1 equals to 6.6 watt. Okay, this is our secondary power. After that, saving in copper. Last is saving in copper. Saving in copper. The saving in copper equals to, what we have to do here? We have to use the formula V1 upon V2. It is V1 upon V2 equals to V1 upon V2 equals to 1400 upon 2500. After solving this, we will get 56, or by multiplying by 100 we will get 56%. That means we save here copper 56% in this case. So we calculate here primary current. After that, we calculate here a load current I2, primary current I1, load current I2. After that, we calculate here I2 minus I1, and the answer is 4.74 ampere. After that, we calculate secondary power, that is the calculated value is 6.6 watt. And after that, we calculate here saving in the copper, and the saving in the copper is 56%. Okay. Now we consider a second numerical. That is a 6655 upon oblique 250 volt 50 hertz step down single phase transformer has 1500 turns on its primary side. Calculate secondary turns, that is N2. After that, cross section area by and considering the flux density is 1.2 Tesla. Okay, now we solve this equation. The solution to the above problem can be calculated as, and for that we have to write given data. So what is given here? V1 equals to 6655 volt, and the V2 is given 250 volt, and the frequency is given F equals to 50 hertz. So this given data is, we know this given data, V1 is equal to 6655 V volt, V2 is 250 volt, and after that frequency is 50 hertz. After that, we know the primary number of turns, that is denoted by N1, is equals to 1500 turns are given, and flux density, that is Bmax, is also given. Bmax equals to 1.2 Tesla. Okay, this given data is, we know this given data. By using this given data, we find out, first of all, transformer ratio. We find the transformer ratio. The formula for transformer ratio is V2 upon V1 equals to N2 upon N1. So by rearranging this formula, we will get N2 equals to V2 into N1 upon V1. By rearranging this equation, we will get N2 equals to V2 into N1 upon V1. So now we put the values of V2 is 250 into N1 is 1500. After that V1 is given 6655. By solving this, we will get the value of secondary number of turns N2 is 56 turns. That means we will find out N2 is 56 turns. Okay. Now the cross section area of the core. Now we have to find out the cross sectional area of the core. So for the cross sectional area of the core, the given is flux density is 1.2 Tesla. So for that, first of all we have to find out the flux, and after that we can find out the cross sectional area of the core. So first of all we use here primary E1 or V1 formula, that is 4.44 into F into N1 into phi m. So we know that the V1 is given, but here phi m is not given. So rearrange this equation and we will get phi m equals to V1 upon 4.44 into F into N1. So now we put all the values, we will get phi m equals to, the V1 is given 6655 upon 4.44 into F is given 50 and N1 is given 1500. So by solving this, we will get phi m equals to 17.84 milliweber. Okay, now we get the maximum value of flux. By using this, we can find out the cross sectional area. To find out the cross sectional area, now we have to use maximum flux density formula, that is B max equals to phi upon 8 Tesla. So we know the flux density and we know the flux, but we don't know the cross sectional area. So by rearranging this equation, we will get A equals to phi upon Bm. So now put the values of phi is 17.84 into 10 raised to minus 3 upon 1.2. So by calculating this, we can get small a equals to 14.866 into 10 raised to minus 3 meter square. This is the cross sectional area of the core, that is 14866 into 10 raised to minus 3 meter square. So by using this given data, that is V equals to 6655V, V2 equals to 250 and frequency is 50 Hz, N1 is equals to 1500 and the considering flux density is 1.2 Tesla. We find out first of all that by using the transformation ratio value of N2, that is number of secondary turns, and we find by calculating the value 56 turn. After that we find out the cross sectional area of the core. For that we use formula of primary induced RMS value of primary induced EMF, V equals to 4.44 into F into N1 into phi m. By rearranging the equation, we find here maximum value of the flux, and after that by using the Bm and rearranging the equation of Bm, A equals to phi upon Bm, we will find out the value of A equals to, that is cross sectional area of the core, equals to 14.866 into 10 raised to minus 3. Thank you.